All right. Good afternoon, everyone. Welcome to the National Science and Technology Week webinar on the synergy of IoT and AI for technology-assisted farming. We're now on our third event this week, and if you're coming back from one or two of our past webinars, welcome back, and thank you very much for the continued support for DOST-ASTI. And if you're new here, let me introduce myself. My name is Nicole Chavez, and I will be your host for today. Now, before we proceed, may we please invite everyone for the singing of the Philippine National Anthem. Okay, once again, a pleasant afternoon to all of you who are tuned in for this very exciting event. I hope you've all had your lunch and have enough energy for the rest of this afternoon because we have a very interesting lineup of activities set up for you today. We're very grateful that you took the time to be here, and we can't wait to show you new developments and presentations on the DOST-ASTI's Gulay project and other initiatives on technology-assisted farming. Oh, so just a few reminders before we start. Please be informed that this online event is being recorded and currently being live streamed on Facebook. So if you won't be able to attend the live stream or not available to be here with us for the rest of the event, you may definitely catch up using the event recording, which you can access via the DOST-ASTI's official Facebook page. Participants may type in their questions in the chat pane to be addressed by the speakers, and moderators
Apologies po. We're just having a little bit of technical problem.
Hi, everyone. Apologies for that technical difficulty. I'm not sure if I can be heard now or seen. Okay, so let's proceed with the program. Again, a few reminders before we officially start. So just some quick house rules. Please be informed that this online event is being recorded and currently being live streamed on Facebook. So if you won't be able to attend the live stream or are not available to be here with us for the rest of the event, you may definitely catch up using the event recording, which you can access via the DOST-ASTI's official Facebook page. Participants may type in their questions in the chat pane to be addressed by the speakers and moderators during the panel Q&A session later. And for those who are streaming this event via Facebook Live, You may send us your questions to our resource speakers by typing them in the comment box, and our team will be relaying them to the speakers during the Q&A session. And of course, to our friends from the media, you may access the official event press kit by visiting the URL now flashed on your screen. You may also email us at media@asti.dost.gov.ph if you would like to get in touch privately with our corporate communications team. For everyone's reference, this is our program for today. So just a bit of background before we start about the Gulay project. This initiative is envisioned to contribute to solving the growing lack of interest of the Filipino youth in agriculture, which may have long-term effects in food security in the country. The project's primary goal is to encourage the Filipino youth to consider taking up areas of study and research and eventually career paths that would lead to the fusion of information and communications technology, or ICT, and agriculture. So through innovation and this fusion, we will be able to ensure our future generations' food security. So all very exciting and interesting stuff here. So I hope that everyone is also as enthusiastic as we are to begin. So to officially kick off our event, let us all watch this video from DOST-ASTI Director, Dr. Franz A. De Leon, for today's welcome message.
A pleasant day to everyone who are present for today's event. Thank you for celebrating this year's National Science and Technology Week with us. We're very excited to show you new developments on a few of DOST-ASTI's projects and programs for this year. It is with great honor that I welcome you all as we share with you new technologies and advancements developed by our talented team of researchers with the goal of benefiting our society. Over the past year, we have been committed and continuously working to deliver relevant and timely technological innovations that provide ease in everyday life for our fellow Filipinos. The current situation caused by the pandemic has further challenged our institute to produce technology-driven solutions that will help make services for our country more accessible to people and for the government to provide accurate data and information to the public. Right now, we have been providing these services to various parts of the country in planning for disaster response, agricultural solutions, and satellite imagery, to name a few. In this event, we will be discussing the Gulay project, which aims to encourage the Filipino youth to consider taking up areas of study and research and eventually career paths that will lead to the fusion of information and communications technology and agriculture. Thanks to our very own developers and researchers from DOST-ASTI, we aim to share with you all how this innovation works and how it is relevant to the progress of society. We are looking forward for everyone to grow more interest and appreciation towards science and technology as we start today's webinar. Thank you and have a good day.
Thank you very much, Doc Franz. Now, before we proceed, just a quick reminder to our media friends and viewers, you can ask questions in the Q&A pane and comment section if you're watching this via live stream after the speaker presentations, because we will be having an open forum and Q&A portion later after our main presentation. And again, to our friends from the press, the official event press kit can be accessed through the website URL now flashed on the screen. And if you would like to schedule an exclusive interview with our speaker, you may reach out to us via media@asti.dost.gov.ph. All right, let's begin. Now, to talk about IoT, connected farming, and smart agriculture, our main speaker is a software engineer and science researcher at the DOST-ASTI. He's held technical leadership and hands-on tasks for the system administration and development team to the software engineering projects under external partners, as well as mobile application and IoT-related internal R&D projects under the DOST-ASTI. He also is currently pursuing his postgraduate studies at the University of the Philippines, Master of Engineering in Electrical Engineering, focusing on computer network security and IoT. Please welcome Mr. Roter J. Copino.
Magandang hapon. Ako si Ruter J. B. Cupino, isa sa mga Science Research Specialist sa ilalim ng Computer Software Division ng Institusyon ng Masulong na Agham at Teknolohiya or DOST-Advanced Science and Technology Institute, aking tatalakayin ang tungkol sa synergy ng Internet of Things and Artificial Intelligence para sa Technology-Assisted Farming. Para simulan ang aking presentasyon, dumako tayo at alamin kung ano nga ba ang Internet of Things. Imagine, nasa trabaho tayo and nakaligtaan natin na patayin or turn off yung aircon and TV. So yung usual na option natin ay umuwi sa bahay, or kung may kasama tayo sa bahay ay tatawagan natin sila at sasabihan na i-off yung mga naturang appliances na nakaligtaan patayin. Pero paano kung gamit ang mga makabagong teknolohiya at ating mga smartphones ay may kakayahan na tayo na manipulahin yung status ng mga kagamitan or appliances sa ating bahay, kahit tayo ay nasa opisina or nasa malayong lugar at nagbabakasyon. Ito ay sa pamamagitan ng teknolohiya na tinatawag na Internet of Things. Internet of Things or tinatawag din ng IoT. Ayon sa simpleng kahulugan ng Internet of Things, ito ay sistema ng magkakaugnay or interrelated na edge devices na may pangunahing pangangailangan na nakakonekta sa internet or network para mapadala at tumanggap ng data mula sa isa't isa. Ayon sa Oracle, ang IoT daw ay network ng physical na mga bagay or things na kung saan itong mga bagay ay mayroong sensors, softwares at angkop na teknolohiya para makapagpadala at tumanggap ng data mula sa iba't ibang devices at system gamit ang internet. Maaaring ito ay pangkaraniwan na kasangkapan sa bahay kagaya ng TV, aircon at iba pa, or mga industrial tools kagaya ng weather stations, sensors at iba pa. Sa likod nitong tinatawag natin na Internet of Things or IoT, ano-ano nga ba ang ilan sa mga teknolohiya na nagbibigay daan sa katuparan ng IoT? Ilan sa mga ito ay una, ang pagkakaroon ng sapat at readily available na low cost at low power na sensor technology sa market na maaari nating mabili sa abot kayang halaga upang makagawa ng isang IoT device. Pangalawa, ang connectivity or komunikasyon. Mahalaga ang existing na protocols kagaya ng TCP/IP, HTTPS or Hypertext Transfer Protocol, MQTT, LoRaWAN, Zigbee, Bluetooth at iba pa upang makapag-usap at makapagpadala ng data ang isang IoT device papunta sa cloud computing platform or ibang IoT devices. Pangatlo, ang cloud computing platform. Sa panahon ngayon, madami nang available sa market na mga solutions na nag-o-offer ng cloud computing kagaya ng Google at Amazon AWS na pinadali para hindi na natin kakailanganin na mag-set up pa ng sarili nating mga server na nangangailangan pa ng karagdagang gastos o halaga sa pagbibili ng mga naturang server. Pang-apat, ang machine learning and analytics. Ayon sa kahulugan, ang machine learning ay sangay ng artificial intelligence at computer science na kung saan gumagamit ito ng data at algorithms para gayahin kung paano matuto ang isang tao at gradually ini-improve nito ang kanyang accuracy. Dahil sa pagkakaroon ng cloud solutions, mas napapadali ang pagkakaroon ng mabilis na access sa data kung saan mas napapabilis ang pagkuha ng insights na maaaring magamit sa paggawa ng desisyon gamit ang mga data at machine learning models. Panglima, ang conversational AI or artificial intelligence. Dahil sa advancement sa neural networks at natural language processing, nagkakaroon tayo ng mga IoT devices na para nating mga personal assistant. Kagaya ito ng mga Alexa, Google Home, Siri, Bixby, Cortana, na karaniwan nating makikita sa mga bahay at mga opisina. 6. Ang device software. Ito ang programa na may tuturing natin na nagpapatakbo sa mga hardware or physical devices natin. Dahil sa software, nakakapag-usap tayo sa cloud solutions, nakakapagpadala at tanggap at basa tayo ng mga data at nakakapag-perform tayo ng mga data analysis. Isa sa mga halimbawa ng IoT ay ang tinatawag natin na smart home, na kung saan sa isang smart home setup, nagkakaroon ng kapasidad ang isang homeowner na kontrolin ang kanyang mga kasangkapan sa bahay kagaya ng ilaw, aircon, TV, water sprinkler, door locks, garage doors, mga power plugs at iba pang gamit sa kanyang bahay gamit ang kanyang smartphone. Or mga personal assistants kagaya ni Alexa and Google sa pamamagitan ng internet. Halimbawa ng smart home setup, sa paggising natin sa umaga sa pamamagitan ng ating smart clock, as soon as na mag-off ang ating alarm sa umaga, maaaring nakasetup na magbukas ng otomatiko ang ating window blinds at mag-off ang mga ilaw or mood lights sa iba't ibang parte ng bahay. Maaari rin na kung meron tayong smart coffee machine, ay pagkalabas natin ng kwarto, nakahanda na ang kape para sa atin at automatic nang naka-on ang television para makapagpanood tayo ng latest na mga balita. Ano-ano nga ba ang mga pangkaraniwan na IoT devices na meron sa market? Una, ang general or consumer devices. Ito ang mga pangkaraniwan na makikita natin sa mga bahay kagaya ng TV, aircon, ilaw, mga camera, smart speakers, smart door locks, or mga bagay para sa smart home or office setup na naglalayong i-automate ang mga household functions. Pangalawa, ang sensing devices. Mga sensor na pang-detect ng external na information galing sa kanyang kapaligiran kung saan ito ay naka-install. Kagaya ng mga sensor na pangkuha ng temperatura, humidity, luminance, galaw ng tao, sound at mga voice command. Kung titingnan natin ang isang simpleng IoT setup, maaari itong kagaya ng figure na ipinakikita sa slides. So maaaring magkaroon tayo ng kombinasyon ng general o consumer devices at sensing devices na kung saan yung magiging aksyon ng general devices ay nakabase sa data na nakokolekt sa ating mga sensing devices. Pagkatapos, ang mga nakolektang data ay ipinapadala gamit ang mga available na communication protocols depende sa ating setup. Maaring wireless or wired communication at ito ay ipapadala sa cloud or servers natin for data collection, storage, processing, and analytics. Dumako tayo sa halimbawa na ito. Halimbawa, sa ating bahay, mayroon tayong bakuran at may mga tanim. Typical na setup ay mayroon tayong gripo at hose na kung saan gagamitin natin para sa pagdidilig ng halaman. Pero paano kung nag-setup tayo ng isang simpleng smart irrigation system na kung saan meron tayong water supply, soil moisture sensor, water sprinklers, internet connectivity, at maaaring din itong ikabit natin sa cloud for data storage at analytics na mga nakukuhang data galing sa sensor. Nakaraang Setyembre taong 2020, nag-publish ang Libelium, isang company na nagpo-provide ng technological solutions gamit ang Internet of Things. Ayon sa nilathala nila na 50 sensors applications for a smarter world, mahigit 50 billion devices daw ang magiging connected sa internet by 2020. Ilan sa mga vertical markets na kung saan posibleng pag-applyan ng Internet of Things ay ang mga sumusunod. Smart cities, halimbawa dito ay smart parking, smart roads, intelligent highways, at smart lighting. Maaari rin ito sa smart environment, halimbawa dito, mga air pollution detection at earthquake early detections. Pwede din ito sa smart water, halimbawa, potable water monitoring tsaka river flood monitoring. Pwede din ito sa smart metering, halimbawa mga smart grids. Pwede din sa smart retail, halimbawa mga intelligent shopping applications. Pwede din sa logistics, halimbawa mga fleet tracking sa mga ports. Pwede din ito sa smart agriculture, halimbawa wine quality enhancing, greenhouses and meteorological station network. Pwede din ito sa smart farming, halimbawa mga animal tracking solutions. Pwede din ito sa e-health, halimbawa mga UV radiation detection, tsaka mga patient surveillance. Sa ilalim ng Industry 4.0 ay ino-optimize yung computerization ng Industry 3.0 na kung saan yung mga computers or objects ay connected and nakakapag-communicate sa isa't isa na hindi nangangailangan ng human intervention. Naging possible ang Industry 4.0 sa pamamagitan ng combination of cyber-physical systems, Internet of Things, and Internet of Systems. Dumako naman tayo sa konsepto ng smart agriculture at connected farming. Ayon sa projection ng UN, sa taong 2050, aabot ng 9.7 billion ang bilang ng mga nabubuhay na tao. Kaakibat nito ay ang paglobo ng populasyon na maaaring magkaroon ng mga challenges. Isa sa mga posibilidad ay ang pagkakaroon ng kakulangan sa food production. Ayon sa UN Food and Agriculture Organization, kailangan natin paghandaan at i-boost ang food production ng at least 70% sa mga susunod na dekada para maging handa tayo sa paglobo ng populasyon sa taong 2050. Pero tila ang pagtaas sa food production ay hindi madaling gawin. Kaya naman, ilan sa mga engineers at magsasaka ay nagtutulungan na naglalayo na makagawa ng technological solution gamit ang precision at smart farming. Ilan sa mga challenges na kinakaharap natin ay food security and hunger. Sa dalawang nakalipas na taon hanggang ngayon, kinakaharap natin ang COVID-19 pandemic na kung saan humarap tayo sa mga nakailang lockdowns. According sa survey ng SWS or Social Weather Station noong nakaraang Setyembre 2020, nagpapakita ito ng 30.7% ng mga Pilipino ay naka-experience ng gutom at 8.7 naman ang naka-experience ng sobrang gutom. Ilan sa mga nagiging hakbang ay ang pagbibigay ng Social Amelioration Program grants or SAP para sa mga low-income families at ang pagbubukas ng mga community pantries at ang pagsusuporta ng backyard at community food production. At din ang pagbili ng direkta sa mga farm produce at ipinamamahagi ito sa pamamagitan ng community pantries. Kailan nga ba natin masasabi na nag-e-exist ang food security? Ayon sa United Nations Food and Agriculture Organization, food security exists when all people at all times have physical and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preferences for an active and healthy life. So dapat may food availability, food access, sapat na utilization ng produced foods, at stable ang production ng mga pangunahing produkto at pagkain. Para masiguro ang kalidad ng mga produkto, ini-introduce natin ang solusyon katulad ng smart farming or precision agriculture. Ano nga ba ang smart farming? Ang smart farming, katuwang ang precision agriculture, ay isang emerging concept na kung saan sa pamamagitan ng integration ng advanced na teknolohiya kagaya ng mga sensors ay naglalayon ito na mapataas ang quality at quantity ng mga produkto or yield at hindi nangangailangan ng buong atensyon ng tao or human labor at nakakapagbigay ito ng accurate na data. Ilan sa mga teknolohiya na bumubuo o ginagamit sa isang smart farming setup. Una, ang sensors. Ito ang mga devices na kumukuha ng external na impormasyon galing sa kanyang kapaligiran kung saan ito ay naka-install kagaya ng sensors para sa pagkuha ng temperatura, humidity, luminance, galaw ng tao o insekto, pagkuha ng kalidad ng hangin, pagkatuyo o pagbabasa ng lupa. Pangalawa, ang software applications. Ito yung mga programa na maituturing natin na magpapatakbo sa mga hardware or physical devices natin. Dahil sa software, nakakapag-usap tayo sa cloud solutions at nakakapagpadala at tanggap tayo ng mga data na nakakapag-perform tayo ng data analysis. Pangatlo, ang data connectivity or communication. Mahalaga ang mga existing na protocol kagaya ng cellular, TCP/IP, HTTPS, MQTT, LoRaWAN at iba pa upang makapag-usap at makapagpadala ng data sa isang IoT device papunta sa cloud computing platform or sa ibang IoT devices. Pang-apat, ang telematics at ang mga positioning technologies kagaya ng GPS, satellite at iba pa. Pang-lima, ang hardware and software systems. Halimbawa nito ay mga robotics kagaya ng autonomous na tractors, seeders, weeders, at mga automated na processing facilities. Pang-anim, ang data analytics, na kung saan ang data na nakokolekta sa mga sensors ay pinoproseso at pinag-aaralan upang makakuha ng bagong data na posibleng maging solusyon sa isang problema o makakuha ng panibagong impormasyon na maaaring magamit sa paggawa ng desisyon. sa pamamagitan ng pagkolekta ng smart machines at sensors gamit ang IoT sa proseso ng pagsasaka, magiging data-driven at data-enabled ang ating proseso ng farming. Pinapakita lamang dito sa figure na ito ang simpleng cycle ng isang IoT-based farming. Una, sa observation stage kung saan yung mga sensors ay mangongolekta ng data, halimbawa, data ng crops, livestock gaya ng lokasyon ng kalabaw or baka, pagkabasa or pagkatuyo ng lupa at iba pang environmental parameters. Sunod naman ay ang diagnostic stage, kung saan yung mga sensor values na pinadala sa cloud-hosted na IoT platform ay pinoproseso, pinag-aaralan, gamit ang mga predefined na decision rules or mga business logics para makatukoy tayo if may kailangan or deficiency ba ang ating farm na kailangan nating tugunan. Sunod sa cycle ay yung decision stage kung saan ang isang farmer or halimbawa gumagamit tayo ng machine learning or AI, maaaring gumawa ito ng desisyon base sa findings o resulta ng diagnostic upang makatugon sa pangangailangan ng ating farm. At ang huli sa cycle ay ang action stage kung saan dito ine-execute yung mga kailangan gawin base sa desisyon na napagtanto ng ating system na kakailanganin sa ating farm upang ma-resolve ang isang problema. At ito ay isang continuous cycle lamang. Ilan sa mga application ng IoT ay una, sa ilalim ng autonomous and robotic labor na component. Halimbawa ng mga ito ay autonomous tractors. Ang tractor ay may tuturing na pangunahing pangangailangan ng isang farm kung dati ay kailangan ng tao para mag-operate ng isang tractor at sapat na kaalaman sa mapa at boundary ng isang farm. Sa pamamagitan ng autonomous or driverless tractors, maaaring ito ay equipped na ng GPS para sa navigation, IoT para sa connectivity, para sa remote monitoring and operation, radar at LiDAR para naman sa mga object detection at avoidance mechanism. Isa rin sa posibleng i-automate ay ang pagtatanim ng buto na isa sa mga matrabahong proseso ng pagtatanim. So sa advancement ng technology, ma-achieve natin ang precision seeding. Isa rin sa posibleng pag-applyan ng IoT ay ang water irrigation na kung saan kapag nag-implement tayo ng IoT-enabled solutions sa mga existing na irrigation methods tulad ng subsurface drip irrigation, maaring mas maging efficient ang pag-monitor natin ng soil moisture level at plant health. At isa pa ay makakapagbawas tayo ng cost sa resources if ang magagamit lang na tubig sa irrigation ay kung ano lang yung kailangan base sa data na nakuha galing sa mga sensors. Isa rin sa posibleng pag-applyan ng IoT ay yung weeding and crop maintenance na component. Isang halimbawa nito ay si Bonnie Rob. Isang AI robot na kasing laki ng isang sasakyan na kung saan may kakayahan siya na mag-navigate sa isang field gamit ang camera, LiDAR at satellite GPS. Gumagamit ito ng AI para mag-identify ng damo na kanyang nadadaanan bago niya ito bunutin. Isa din sa kilalang application ng IoT sa farming ay yung tinatawag natin na autonomous fruit harvester. Halimbawa nito ay maaaring ma-automate ang pagpitas ng mansanas sa kanyang puno sa pamamagitan ng technologies gaya ng mga sensors, robotics at AI para malaman if good harvest na ba ito. Sa ilalim naman ng imaging and planting, maaari din natin magamit ang drones at magsilbi itong bird's eye view ng mga farmers. Dahil din sa liit nito, mas madali itong mamanipula at cost-effective para makakuha ng aerial photographs ng isang farm instead ng pagkuha gamit ang helicopter na nangangailangan pa ng piloto at cameraman. Maaaring magamit ang mga drones sa pagtatanim ng mga punla or buto. Halimbawa nito ang drone seeds at biocarbon na gumagawa ng drones na nagtatanim ng buto ng mga puno sa isang optimal na lokasyon. Ang layunin nito ay para sa mga reforestation na proyekto. Maaari din magamit ang drone sa pag-spray. Halimbawa nito ang drone ng DJI na tinatawag na Agras MG1 wherein sa pamamagitan ng radar, IoT, nasisiguro ng drone ang kanyang tamang distance at coverage ng area na kanyang liliparan at paglalagyan ng fertilizer, herbicide, or pesticide. Pwede rin ito magamit sa real-time monitoring and analysis para naman makakuha ng visual sa crop conditions sa ibabaw. Sa isang traditional na greenhouse, yung control ng environment parameters sa pamamagitan ng manual or inconsistent na proseso ay kalimitan nagiging sanhi ng production loss, energy loss at additional labor cost, kung saan mahalaga sa isang greenhouse ang accurate na microclimate at agroeconomic parameters. Ngayon, sa pamamagitan ng mga available na sensors, communication technologies at IoT, nagkakaroon tayo ng smart greenhouses kung saan nakakapag-record tayo ng data ng surrounding at ng pananim 24/7. Ang nakokolektang data ay pinapadala at ini-store sa IoT platform na nasa isang cloud computing kung saan pinoproseso ang data upang makabuo ng bagong impormasyon na maaaring maging solusyon sa isang problema, halimbawa, pagdiskubre if mayroon bang crop disease at infection risk na maaaring mangyari sa loob ng isang greenhouse. Isang halimbawa ng IoT sa product quality enhancing ay ang pagmamonitor ng soil moisture at trunk diameter sa mga vineyards. Sa pamamagitan nito, makokontrol ang amount ng sugar sa grapes at mamomonitor ang kalusugan ng grapevine. Sa pamamagitan ng high precision grape control at data-driven na vineyard management, magiging malaking tulong ito para sa mga winemakers sa pag-a-analyze ng data para magamit sa paggawa ng desisyon. Isa din sa advancement sa agrikultura na sektor ang pag-implement ng mga automated weather stations. Halimbawa nito ang Next Weather Stations kung saan kumukuha ito ng data kagaya ng temperature, humidity, left wetness, wind speed, wind velocity, soil moisture at iba pa, na kung saan ang data ay pinapadala sa pamamagitan ng cellular network, pwede ring narrowband IoT or LoRaWAN. At base sa mga nakalap na data, maaaring makakuha ng insights halimbawa sa mga posibleng sakit at peste na dadapo sa mga pananim at kalakip nito ay ang posibleng maging forecast ng panahon. Ilan sa mga benepisyo na maaaring makuha kapag ginamit natin ang IoT technology sa agrikultura ay ang posibilidad ng pagtaas ng quality at quantity ng ating crop yield. Pangalawa, mas marami tayong mga data ang makukuha at mare-record sa sistematikong paraan na kung saan magagamit natin ito upang makapag-draw ng mga kaalaman about sa pananim at sa yields. Pangatlo, kapag nasiguro natin ang pagkabawas ng yield loss at pagtaas ng food availability, posibleng makatulong ito upang masiguro natin ang seguridad ng pagkain. Dahil sa pag-introduce ng IoT, binabawasan din ito ang human interventions, pero hindi ibig sabihin na papalitan nito ang human labor. Sa halip, ito ang magiging katuwang ng mga tao upang mas maintindihan pa ang mga bagay-bagay tungkol sa pagtatanim at pag-aani ng mga taas na kalidad ng produkto. Panglima, makakatulong din ito sa pagbabawas ng operational cost at masisiguro ang resource waste management. Sa mga initiative ng government pagdating sa smart agriculture ay ang mga sumusunod. Una, ang Project SPICE o Smart Plant Production in Controlled Environment, na kung saan ito ay naglalayon na maging lead research and development para sa standalone urban farm systems at makapag-establish ng protocols para sa micropropagation, cryptopreservations, at pangangalaga at pagpaparami ng mga rare, endangered, and economically valuable na mga plant species. Ito ay sa ilalim ng DOST shared katuwang ng UP Diliman Institute of Biology and Electrical and Electronics Engineering Institute at UP Los Baños Institute of Biology. Sa ilalim ng DOST-ASTI, nagkaroon din ng initiative ang mga researchers sa pagbuo ng isang proyekto na naglalayon na makahikayat ng mga kabataang Pilipino para magkaroon ng interes sa area ng agrikultura sa pamamagitan ng fusion ng information and communication technology at agrikultura sa pamamagitan ng pag-implement ng portable, microscale at automated na plant growing platform. Ang objective ng proyekto ay makapag-develop ng prototype ng isang IoT-enabled na plant growing platform na kung saan Meron itong mga sensors kagaya ng temperature, humidity, moisture, light, water level monitoring, and nutrient monitoring. Pangalawa ay makapag-develop ng isang online information management system para sa data na nage-generate sa platform. Ito ay sa pamamagitan ng web application at mobile application. Pangatlo ay makapagsagawa ng field testing, conduct ng mga trainings at makakuha ng feedback mula sa end users at target beneficiary para sa continuous improvement ng proyekto. Ilan sa mga na-develop na functionalities ng Gulay, una ay ang plant growing module or ito yung hardware component na kung saan meron itong mga sensors na minomonitor yung tanim sa loob ng module. Pangalawa, web application at REST API. Sa pamamagitan ng REST API, malalagay sa backend yung mga data na nag-generate mula sa platform or hardware component. Sa pamamagitan naman ng web application, ito ang magsisilbing user interface para sa mga researchers na gagamit ng system para magsimula or mag-monitor ng kanilang mga experiment remotely. Pangatlo, sa pamamagitan ng mobile application, mas magkakaroon ng portability ang mga researchers sa pag-monitor ng kanilang experiment at maaari silang magsimula ng experiment sa pamamagitan lamang ng kanilang mga smartphones. Ang Project Gulay ay kasalukuyang nasa development and testing phase. Ayun lamang po ang hangganan ng aking presentasyon. Maraming salamat po sa pakikinig at magandang hapon po sa lahat.
Thank you, Sir Rother. So for the next portion of our program, we will start the open forum and Q&A session with the Gulay Project's development team. So to join us here as panelists for the open forum, may I call on Sir Jeffrey Aborot, and once again here on our virtual stage, Mr. Rother Copino. Sirs, please turn on your cameras and be ready to answer questions. So again, for those of you who are streaming this event via Facebook Live, you may type in your questions on the comment box, and to our attendees here on Zoom, we have a Q&A pane, which you can see at the bottom of your screen. So if you have any questions, you can type in your questions there, and we'll make sure to relay it to our panelists over here. All right, so let's proceed to our first question. I think both of our panelists could answer this question. So the first question is, can you share or distinguish the significant features of both the web and mobile app components of Gulay? Sir Rother, yes, please go ahead.
Hello po again. Good afternoon, everyone. So to answer the question po, both the mobile and web application has the same functionality, wherein the end users has the capability to create, update, and monitor their experiments and their experiment profiles and also research journals. And also through the applications, they can visualize yung data gathered from the platform and experiment runs. In addition sa mga features ng web application, meron din siyang platform and research project management. Ayan po. Thank you.
Okay, thank you, sir. If you would like to proceed to the next question, the second question is, how do you envision and aim to encourage the youth to benefit from the technologies discussed? And furthermore, where do you see this project going in the next 5 years? Yes, Sir Jeff, go ahead.
Hello. We hope to eventually license the technology to the private industry, so that it can be mass produced, and so that the universities and secondary level schools will have access to the technology for their own research in agri-science. And hopefully the final product will reach all the corners of our country. So even sa mga rural areas, hopefully magkakaroon ng access yung mga students high school pa lang, so that they would be encouraged to take up courses relating to agriculture science, I mean.
Okay, thank you, Sir Jeff. For the next question, the third question is, do you have any ongoing or upcoming partnerships in the pipeline? So is this something that you're planning to pursue in the next months or years? Yes, Sir Luther.
Currently, yung Gulay project is in its early stage of field testing. And along with the testing phase, ASTI is about to sign a MOA with University of Rizal System as one of our target partner of the Gulay system. Ayan po. Thank you.
Okay, thank you, sir. For the next question we have is, does DOST-ASTI have any other upcoming projects focused on technology-assisted farming? Yes, Sir Jeff.
Actually, ASTI has a group currently, yung Datos group natin, which is doing R&D work in satellite-based mapping technologies, no? So yung mga results ng Datos team have already been adopted in several LGUs in the country to help the farmers, no, to see, for example, yung condition ng farmlands natin, let's say after a typhoon, so they would see yung coverage nung or effect ng flooding sa area nila. And even yung, for example, farmers would like to see the extent of growth of, let's say, some crops like sugar sa area nila. So may technology na rin na develop yung Datos group ni ASTI on this using satellite images. And for the Gulay project naman, by 2022, the project development team will be pursuing the vertical version of the Gulay system. So this will allow researchers to grow more plants for their experiments.
Okay, thank you, Sir Jeff. So as mentioned by Sir Jeff earlier, if you want to know more about either the Datos project or the Gulay project, both projects are we do have publicity materials for both projects, as well as infographics, which you can access on the digital platforms of DOST-ASTI. So that's on our website, our Facebook, and Instagram and Twitter accounts. So in relation to the fourth question, the next one we have is also about the Gulay project. So one of our guests would like to know if is Gulay open source?
Can I take that one?
Yes, sir. Go ahead.
As of now, no, dahil ongoing pa yung development ng system, hindi pa finalize yung licensing options for the source code and even the hardware component. But we will be working on the licensing of the system probably by 2022 with ASIS Technology Licensing Office. So whatever the licensing options that will be provided for the system, the team will let the public know through ASTI's media platforms.
Okay, thank you, sir. The next question is, again, I think from one of our guests on the live stream. Are there any toolkits that high school students or even younger students can use so they will be involved with agri-science, particularly with IoT? Yes, Sir Luther. Go ahead, please.
Aside from toolkits po, we will provide parang assembly manual, instructional manuals, and also conduct trainings for the students and yung mga SUCs na pag-deployan ng gulay system. Ayun po.
Okay, thank you, sir. Sir Jeff, would you like to add to that?
As Ruther has mentioned, no, we will be providing instructions both for the software component and the hardware component of the system, so that yung mga students natin would also know no kung paano ba binild yung system. So in fact, part kasi ng ano yun, no, part ng goal natin to encourage the younger generation to get into courses in college wherein they will be able to use information technology to help yung ano natin, yung agricultural sector natin sa country. So hopefully through the project no ma-inspire yung ating mga high school and college students to consider yung career sa agri-tech or agri-science.
Okay. Thank you, Sir Jeff. Thank you, Sir Ruther. For the next question we have, it says here, magandang hapon po. Ano-ano po ang mga hakbang na dapat gawin ng mga LGU sa rural area para magamit ang teknolohiya? Yes, Sir Jeff.
Okay, so as of now po, no, ang mga nakakausap pa lang po ng project development team basically ay state universities. And as of now, the intention is to course through the state universities. Yun pong pag-reach out natin sa LGU because the reason din po na andyan yung ating mga state universities is to to assist our LGUs in providing solutions to problems within their domain. So we will also explore other options po no on how to directly partner with our LGUs for them also to be able to access and use yung eventual final product ng gulay system. But probably that will be 2022 onwards.
Okay. Thank you, Sir Jeff. For the next question, one of our guests said, what I have heard from the discussion are purely advantages of IoT and agriculture. May I know what are the fallbacks or not so good things about IoT or possible problems involved with it? So would you like to discuss further, sirs?
Can I have a
Yes.
take on this?
Yes, please.
Yeah, actually this is a very good question. No? Laging two-sided ang technology. So it can be used for good or for bad. And for the case of IoT, no, dahil ano siya connected network of sensors na kung saan yung output ng sensors will inform yung end user on how to decide in a particular scenario. So and so may malaki yung effect, no? Malaki yung effect ng output ng mga sensors doon sa decision making ng end user ng technology. And so just like other ICT related na mga technologies, of course there is the danger nung mga security related na issues, no? So syempre may possibility na kung hindi na-develop ng maayos yung system, then it could be hacked and we don't know what could happen, no? So for example, lalo kung critical yung sensors, like let's say sensors measuring some values, no, relating to human health, and then based from the results of the sensor, no, respond yung isang system on how to let's say blood sugar, no, paano pababain yung blood sugar ng patient. So I think these days may mga sensors na parang pinapatch na lang sa body to measure yung level ng blood sugars ng patient, and then makaka-receive ng information yung end user. And so if ever na magkaroon ng intrusion sa mga ganong systems, then it might be dangerous for the patient kasi pwedeng matamper yung data niya. So that is one siguro possible na danger sa mga interrelated or interconnected na technologies dito sa IoT.
Okay, thank you, sir. For the next question we have, one of our guests are asking, how can private research university can collaborate with you? Please advise. I think this is also related to the next question we have as a follow-up. They're asking if the Gulay system will be implemented only to SUCs. How about private universities who would like to be involved with this? Yes, Sir Jeff.
Actually, we don't really we don't really discriminate kung private or government na institution. As long as mag-express ng interest, then we'll be very willing to collaborate with the institution. So kailangan lang po na ma-inform lang si ASTI about the interest, and then we will get in touch po agad with the institution. As of now lang po, may mga nauna lang na SUC na naging subject to partnership, but hindi po siya limited to public institutions. Of course, we'll be very willing to partner with our private institutions as well.
Thank you, Sir Jeff. So for anyone who would like to collaborate with the DOST-ASTI on technologies like this, you can send an email addressed to our director, Dr. Franz De Leon, and then you can send that over to info@asti.dost.gov.ph, or if you would like to directly get in touch with our project teams, all of their contact details are posted on the DOST-ASTI's official website. So I think we have room for one more question. I think this is for Sir Jeff. For IoT and AI to go hand in hand when it comes to data gathering and monitoring. However, there is what we call experience-based planting, where agriculturists and farmers understand factors such as placement, crop rotation, etc. How will the system adapt to these, and how will this help encourage the youth to pursue the field in helping our agriculture development? Sir Jeff?
Actually, mahalaga po talaga yung yung experiences ng mga farmers natin as input doon sa development ng mga technologies like Kulay. And through our partnership din po with siguro as sa mga naunang partnership natin with SUCs, we hope to be able to tap po sa mga partner din nila ng mga farming communities, since yung pong mga colleges nila na particular sa agriculture science, meron na po silang mga existing partnerships with local farming communities. And so we would want to take advantage po ng mga existing na linkages ng mga SUCs natin and private institutions with these local farming communities. And dapat po talaga na-infuse natin yung experiences ng ating mga let's say in this case farmers doon sa technologies na ginagamit natin, because this will affect them in some way or another, no? Yung pinaka siguro scope po ng Gulay system as of its current design, no, is yung mga agriculture scientists natin, no, who who are working on R&D projects to further improve yung mga crops natin. And of course, nagbabago na din yung panahon, and we need more resilient crops na pwede nating ma-grow locally. And so, yun po talaga yung pinaka-goal nung system, to be able to provide a tool, technology-based tool sa ating agriculture scientist na an aspiring agriculture scientist and agriculture technologists sa pag-conduct nila ng mga R&D na projects nila sa either sa private industry or sa public or private universities.
All right. Thank you, Sir Jeff. Sir Ruther, do you have do you want to add anything to that, or do you have any other insights that you would like to share?
I'm okay na po.
All right. Thank you. So that wraps up our last question for this Q&A portion. Unfortunately, we're a little pressed for time, so that this officially ends the open forum part of our event. Again, big thanks to our guests for your questions and your active participation throughout this event, as well to our panelists, Sir Ruther, Sir Jeff. Thank you very much for taking the time to discuss more about these initiatives. So if you have any more questions that weren't discussed here today, no worries, you can still send us an email at media@asti.dost.gov.ph, and our team will make sure to relay this to the project team. And to all our guests, one last thing before we end, maybe please invite everyone to turn on their cameras for a quick photo op. Our team should now be promoting you all as panelists to enable your cameras. All right. So while we're waiting for that, just a quick reminder to everyone, don't forget to catch the DOST-ASTI's last webinar for NSTW 2021 happening tomorrow, 1 p.m. on machine learning, alternative or supplementary method for short-term weather forecasting. Our main speaker will be Mr. Elmer C. Peramo of the DOST-ASTI. He will also be joined by some members of the Understanding Lightning and Thunderstorms Project, or the ULAT project team, as members of the panel. Apart from that, we also have 4 other events happening tomorrow in celebration of the National Science and Technology Week 2021. So tomorrow, Friday, 8 a.m. to 10 a.m., we have the Nuclear Applications in Health and Medicine, organized by the DOST Philippine Nuclear Research Institute, or PNRI. 10 a.m. to 12 p.m., we have the Big Mo sa Ifugao, launching of the complementary food processing facility in Ifugao, organized by the DOST Cordillera Administrative Region and Ifugao State University. 12 p.m. to 2 p.m., we have Enhancing Regional Innovation Ecosystem, learning from Orobest and Iligan NICE Innovation Programs, organized by the DOST Regional Office Number 10. Lastly, 2 p.m. to 5 p.m., we have Reimagining the Future of R&D with next-gen researchers, a roundtable discussion organized by the DOST Philippine Council for Industry, Energy, and Emerging Technology Research and Development, or DOST PSHERD. All right, I think everyone is ready. So Aldrin or Louis here from our team will be giving everyone a cue for our photo op. So everyone, please hold your smiles and wait for our cue.
Hello everyone, once again, we're inviting to take on your cameras and hold those smiles as we take this opportunity for photo sessions. All right, in count of 3. Smile, 1, 2, and 3. All right. I think that's it for the photo opportunity. Thank you, everyone.
All right. On behalf of the entire Department of Science and Technology, Advanced Science and Technology Institute, thank you very much for being with us this afternoon. This has been Nicole Chavez, your moderator. Stay safe, stay curious, at magandang alam po sa ating lahat.